In this lesson, I want to show you some really quick and dirty ways to rig something. And it's really always a good idea to find really quick ways because sometimes you'll be really bounded by deadlines. Here we have a butterfly model made of splines that is actually a free Illustrator file I found on the net and imported in Cine 4D. So you can see these are all splines. I only created this simple hierarchy, so wings and tentacles are children of the body, and it is all grouped under a single null, so we can actually move that guy around. In this case, I want to make this little guy to flap its wings, but first we will add some geometry to it, so I will put everything under extrude NURBS object. I will hold my Alt key and you will see that nothing happens. And the reason nothing happens is simply because you have to enable this hierarchical mode. I won't say that word twice. So now it will actually go down through the hierarchy and extrude all the splines. I'll set this to 0 simply because butterflies are not really thick. I could actually create different extrude NURBS for the body or a completely different mesh, but this will be good enough for what I'm trying to show you. I'll also create material because I want to give some sort of nice color to my butterfly. So let's pick some, let's say something like this, and we will apply it on the extrude NURBS. So now we actually have a really nice bluish, greenish butterfly. These kind of setups are really usual for some sort of vector graphics or commercials or stuff like that. So it's a really good idea to understand how to rig something really, really quickly for those kinds of target media. So if I want to actually go to my side view, let's say front view, if I want actually my wings to flap, then if I select, let's say this right guy, I want to position the axis roughly around here, and the same thing for my left guy. And you can see the axes are a little bit different. So on the left guy it's completely in the center, and here is let's say somewhere on pretty much odd position. So instead of really positioning them precisely with that structure axis center, I will just press the P key, enable the snapping. Only 3D snapping and point snapping should be enabled. And I will go to my axis mode and simply do that manually because I don't want to waste time with that. So this is something like this. Also for this left guy. So that axis should, that origin of rotation we are looking for should be really here, because that is really a logical thing to do. I'll deactivate the snapping, don't forget to do that. I'll go back to my perspective view. So now we actually, if we rotate this, the wing will rotate from its logical point. Most of you probably noticed that I really picked up on the pace on this last few lessons simply because it feels natural to do so. I expect already that you are really quite familiar with Cine 4D and rigging because of the previous lessons and especially because of the previous volumes. So I don't think it will be necessary for me to explain every single step in real detail. So what I want to do here is actually to give that wing a random rotation, so it's randomly flapping around, and I want to keep this null as a master controller so I can freely move that butterfly around. And for that purpose we will use a vibrate tag. You can find it here under Cine 4D tags. It is near the end, so vibrate. And here we want to enable the rotation. So now we're basically saying that we want to rotate back and forth in 30 degrees. And this frequency setting is actually a speed. So if you press play now, Watch what happens. It really randomly flaps those wings. You can enable this regular pulse, so it will be really uniform. It won't, so it will always go this value of degrees in one direction and then in opposite direction. Really tune down this frequency to, let's say, 1. Maybe this is a little bit slow. Let's try 1.5. Something like this. Maybe increase this to, let's say, 40. We have a little bit more of flapping. Let me stop that now. Go back all the way. So I have a nice and clean value now. And now we have a working setup on this right wing. The problem is we wanted to work on this wing also. And many of you will say, okay, let's put a constraint tag, which is really logical, and simply create that wing a parent. So of course we will use maintain original, so it doesn't pop to this axis, and add a target, and we will be really smart and drop this left wing and say simply follow the rotation. But watch what happens if we do that. This is odd. This is not good at all. So we stop it, go back, have nice and clean values, and this parent constraint simply won't work. And it won't work simply because it is not designed to do that. Because if you take a closer look, if this left guy rotates in this direction, and let me do that, and we say to this right guy to do the same, to follow the rotations of this left guy, this is exactly what will happen. And this is not good. It simply shouldn't behave like that. It should behave a little bit differently. So basically this right wing should be, let's say, behave like in a mirror. So completely opposite. If this is rotating in plus direction, this should rotate in a different direction. I hope this makes sense. So imagine a virtual mirror right in the middle of this setup. So if this guy rotates like this one should rotate in a different direction. Let me undo that. And we have a mirror constraint here in the constraint tag. So let's activate it. And our target in this case is a wing left. But we want to use this body as a center of our mirror plane. So we want to put a mirror plane right in the origin of that body. So we will activate an object here because we want to use an object, and we will simply drop that body inside. So let's now give it a shot and see what we have. We will go back because nothing happens, because we have to enable this rotation. So let's do just that. Let's give it a shot. And it now really works as it should. It simply mirrors the rotation of this left guy. So if you play with the settings here, for example, you can increase the value, it will really flap much faster. The nice thing about it, you still have the option to move and rotate your butterfly completely. So this is a really nice, quick and dirty way to create some sort of rigs that would simply appear elaborate at first, but they are really simple to achieve. So let me show you a next example. Let me show you another quick and dirty method of rigging. This will also give us an opportunity to meet this IK spline, which can be really useful in some situations. As you may have noticed, we have some sort of a spring object here. I will just name it spring. And to rig this in some sort of a fashion that I intend to, without that IK spline, that would be practically impossible. Okay, so the very first thing I want to do is actually I want to create a joint chain here from the start of this top of the spring to the bottom, and of course I want to have quite a few joints in between. And this task can be pretty difficult with this joint tool because you would have to turn on snapping and really slowly build the joint chain manually. And that is exactly what we want to avoid every time when we work in Cine 4D, because that is time consuming. A good approach when you have to create a really long joint chain with many joints and they have to be equally spaced is to actually create a spline. Let me create a linear spline. I will create a point here, and I will select them both and zero out their values, both on size and position X, so they are really in the center, and I can also put this to 0 on the Y, so it's completely in the middle here. The reason that I'm doing this is really simple. Now I have the ability, I can actually subdivide the spline if I press the U and S, and let's enter 8 instead of 10 subdivisions, so we will have additional points formed. Let me just hide this spring object, and you can see we have equally spaced points on that spline. Good thing about this now is that you can actually go here under character menu, and under conversion you can select spline to joints. You can see it will create a joint for each point, so that is really a fast way to do complicated long joint chains. Now here we are presented with the joint chain. We just unfold it all. So you can see the problem. All these joints are called, well, joint. So there is no really a logical distinction between them. So we will have to rename them. So let's select the first one, and I'll just press the numbers as I go down. So let 5, 6, 7, 8, and the last one is 9. So this is a rather fast way to rename multiple joint chains, and I tend to really use numbers. Also, maybe this is a good opportunity to show you the naming tool. Here under character menu, we have a naming tool, and you can actually add prefix or postfix, or even replace the names inside the joint hierarchy. Too bad it doesn't have an option to automatically renames with, let's say, a range you will set. In this case, numbers. I would prefer that kind of setting. So let's say we want to add a prefix to all our joints, so we'll select them all and simply add here spring, because we have a spring as an object, so let's add that as a prefix and hit replace name, and every joint will get that addition. So this naming tool can really save you a lot of time in certain situations. Now, before actually doing anything, let's go back to our perspective view and back to model tool. Don't forget to align your joints properly. You also change the display of the joints, so I prefer this line, and size could be maybe a little bit bigger, something around 8. And also in this situation where you will be building IK spline setup, it's also important for this Z guide to point down the chain. So let's do just that with our joint align tool, and if we hit align now, those joints will properly align on the Z axis. Now we are pretty much ready to go. So let's middle click our first joint. That will select all of them, and we'll select our spring guide, unhide this hyperner so we can actually see the spring object, and go simply once again, characters, commands, bind. This will bind this joint chain to a mesh, and you can see it's moving the complete setup simply because this is the parent. But if we select, let's say, a less guy, it will do nothing because you may remember that last joint is never weighted to a mesh. So keep that in mind. You will see that this one actually does something. In this IK spline we will build, we will apply weighting to all these joints, even this last one. So let's add that IK spline tag. You can find it just below the classic IK, and they pretty much operate on the same way. So we have to define the end of your chain, which is very logical. This is this last joint. And we also want to define the spline which will be used to deform this mesh. So you can use this spline we created for joint conversion. So now it will do absolutely nothing. Well, almost absolutely nothing, because well, nothing will happen until you create handles. In this case, the handles are actually the controllers that will be created from the positions of these joints. I have to warn you prior to this that this can be a little bit tricky, because when you hit add here, you will have the ability to control which one of these guys is used to create a controller with this button based on their index value. And this can be a little bit tricky, since this 0 is the first guy in the hierarchy. And following the same logic, this last guy will not be a value of 9. It will be actually a value of 8. Since 0 is calculated as a starting point, not a value of 1. You can actually help yourself by naming those joints from 0 to 8, but I wanted to show you the problem, so don't be confused by this. Simply look and count, if you can, what is the first value. So let's say I want 3 controllers. I want a controller for the top and the bottom, and also for the middle. So let's hit add 2 times, and we will get 2 additional objects we can create. So let's now carefully create those controllers. The index value of 0 is the first guy, so that is quite okay. We will hit create. That will create a null object with a 0 to it. It will always add a value to a name. So this is okay, and if we hit our standard controller script, you can see it actually is created from that first joint. So the second controller should be in the middle, so let's count it just to be safe. So 0, 1, 2, 3, 4. So actually this spring joint 5 has an index value of 4. So let's create that controller. Let's see if we did it correctly. Hit standard controller script, and we actually did. Of course, in the same manner, we will do the same for the last guy, because we want to create another controller from this joint. And we can do once again a simple counting. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is actually an index value of 8. So let's put 8 here, create that controller, give it a standard controller value. Here we created before, and you can actually see that is correct. So we have a controller for top, middle, and a bottom. I hope this is not too confusing, because it can really drive some people mad with that indexing feature inside the tag. If you don't like this approach, you can actually convert manually to nulls. So you can select each of your joint, convert it manually to null, drop it here, but this indexing will stay the same. So we'll have to find which of the joints should be controlled with a null created from this index value. I really hope this is not too complicated. So let's give it a shot and see what do actually those controllers too, and it is a really good idea to select all these guys like this and freeze the transformation. So we'll have again an option to reset the positions and the rotations of those guys. So let's give it a shot. Let's select this top controller. We will actually name them. So this will be top, this one should be middle, and this should be bottom. So let's select the top controller and try to move it and see what it does. And you can see it's working its magic. And it can behave differently, but you have to set that here under type. There is an obvious difference, so you can set it to equal. And now it will behave like a stretching type. You can also see we have some problems with weighting, so we have a play with these values. You see this really takes it all and deforms it based on that spline. And this equal guy will really try to stretch that spring to its maximum. Okay? So as you can see already, we have some weighting issues here, and we can fix that. Let's select our weight tag, and we will hold down the shift key and double click on it. This will open our weights manager. Let's go to auto weight, and we will select all joints, because as you remember, the last joint has no weights applied, but we want to apply it on the last one also. So if you hit calculate now, just turn off hyper nerves. Let's hit calculate, and we will have a messy result. That is because you shouldn't weight IK spline setups if they're not in default position. So let's go to default position, and we will do our weighting now. So I'm really trying to show you what kind of traps you will encounter. So let's select all joints, hit calculate. We will probably say nothing will happen. But we are in fact now sure that all joints we selected are weighted to this mesh. Now you can select your controller, and although you really shouldn't weight the mesh in deformed position, you can actually smooth it. So here under smoothing, select all joints and really smooth this quite a few times till you solve this problem. If you're unable to solve it as it is, increase this value, increase this distance, and give it a shot once again. Distances between smoothed points have to be inside this value. Let's give it quite a few smooth hits here, so you will have now a really clean deformation. You can really see that live. So let's reset the position. So all those controllers work, and you can see how we clearly speeded up the workflow with these reset guys, and some things would be really slow without it. Of course, you can test your other controllers, even this middle guy, and based on what you have set here, the type, that's how that IK spline setup will behave. Here you can actually set the twist, so your spring could actually twist if you rotate the controller. This IK spline is really useful in, let's say, controlling a character's spine or stuff like that. So you can create some sort of a snake setups and similar things. I hope you really didn't have any problems following this IK spline setup. So let me show you another little setup. This is not exactly a rig we will do right now. It's more of a setup really, but I think it's really fun and can help to get more insight on what Espresso can actually do. So we will have a little bit of fun and build a simple counter, and it's all about tailoring Cinema 4D to your needs. And I'm sure you've seen some sort of a counters in commercials and stuff like that. So let's cover that. I think that is really fun and really good to know. So the general idea would be if we had some sort of, let's say, text object. In this case, we would use a spline and simply clear this text box, so we have no text at all. So what we would like to do is actually to create a setup where you play the animation, and as the time progresses we want some numbers to appear here. So we will get number 1, 2, 3, or whatever number we put there. Okay? So some sort of a counter, interactive counter in the viewport. That is actually pretty simple with Expressor. So let's add an Expressor tag. Of course, I will dock it. So if we drop this text object and find our time node, so as the time progresses, we want to say to this text to change. So we find the text value on object properties. So that is this guy, and let's simply connect them and see what do we get. So let's hit play, and you can see we have some sort of crazy values going on, and that is really disturbing. And if you just take a moment to actually dissect what is happening here, you will gain a lot more understanding of what will come next. As you can see, this number here, 1.433, what does that actually mean? Well, if we scrap time all the way to, let's say, frame 30, you will get the value of exactly 1. Why? Well, if you press Ctrl D, you will see here under frames per second, this is actually your complete project setting. It means that 1 second will contain 30 frames, and that is exactly what we have here. So after 30 frames, we get a value 1, that is 1 second. Naturally, if we will go to, let's say, frame 60, we would get a value of 2, that means 2 seconds. And everything in between those, let's say, rounded values is the frames in between. So how it calculates them. You can clearly see that. For example, here under, let's say, frame 33, actually, you have a value of 33 and 3. I hope this is pretty simple to understand. So what is actually happening, that text object is receiving that frame values and simply stating them here in the viewport. I actually want to change that, because in this current situation we are actually not getting round numbers. We are getting every kind of numbers. So we have to find a way or a node inside Expressor that is able to round the numbers. So let's say that value of let's say 1.233 should become a value of 1. So it has to be rounded to nearest number. So it probably we could set it to be rounded in the negative direction, that means 1, or into a positive direction. That would mean that this number would be rounded to value of 2. I'm really trying to simplify this as much as I can, and some of you would probably say, well, this is not really technically correct, but just for the sake of better understanding, I will maybe make a few, say, tiny mistakes that are not really mistakes, but that will actually help you to understand it a bit better. So as I mentioned in volume 2, I had a really nice comparison. For example, if someone asks you how much do you weigh, you will probably answer him in kilograms or pounds or something like that, but you actually weigh in newtons. But it is really common for everyone to understand pounds or kilograms, so I will do such mistakes, such comparisons, so it's easier for you to understand. Let's continue with our setup. Let's go all the way back. Here in Espresso there is a nice node here under calculate, and it's called float function. And this node is actually able to round up numbers. So if we feed this value of time into our float function node and also drop a result node, this result node is really good stuff. It will tell you actually the result that you have from your node. So if you press play now, let's see what happens. I'll just break the connection here so it doesn't bother us. So once again, you can see if I stop the animation, the value will change. So we have to enable this animation refresh, and the values will change constantly. So look now. It is giving us the result here, and the result is equal to this function here. Before your head starts spinning, really, this is really simple math. Here you have floor and ceiling functions, and floor means it will round it to a negative value, so it will go in negative direction. So that would mean in this case 17. Or if I put a ceiling here, just play it will round all those numbers to a next round number. So you can actually see we are getting only the round numbers as the result. We go back, and now if we also connect this to our text, go back and hit play, we will actually have a counter. So it counts as the seconds pass by. You can actually increase the time to, let's say, 1000 frames, so we have a little bit more space in our animation, so the numbers will change accordingly as the time progresses. So this number is mathematically correct. So it's really counting real seconds. Let me stop it, go back, and it's really nice. So now we are really happy because we have our counter. So as you press play, it will count the seconds and give us the live feedback in the viewport. And now the obvious, what if we want this to count down from a specific value but in negative direction? So let's say we want it to count down from 10 to 0. And I know this may be a little bit boring, but you will have to understand Espresso, and simply there is no way you will become proficient in rigging and creating setups if you don't have at least a decent grasp of Espresso on what those nodes can actually do. That's just the way it is. You'll once again do a logical setup because Espresso is all about logic. So we have to find a way to state here value from which we will count down. In this case, there is a value of 10. So let's do a constant node here and give it a value of 10. So now we actually have that constant value from which we want to count down. So let me just break this connection and show you. I'll go really slowly with this. And connecting these guys can be a little bit difficult sometimes when you're using a tablet like me. So now I just pressed play to refresh that a little bit. You can clearly see that I can change the value of the text by simply changing the numbers here. So that works, that part of it works. So how do we say to this text object that we want to count down from this 10 to, let's say, 0? That is actually quite simple. Let's press play and once again see what happens. You can see this number is increasing. So in any frame, if we subtract this value from this constant, we will actually get what we want. So let's give it a shot. So I will create a math node, and this is really a simple operation. So our first value should be this constant. So it's the value of 10 in this case. So now the input one is 10. the second value should be calculated by this time. So that is actually this value here. So we want to connect this to a second input. And here I will simply say subtract. I want to subtract input 2 from input 1. Okay, so hopefully I haven't lost anyone. So let's hit play. And you see it's actually subtracting this number from this constant. And it's really nice because it's dynamic. It works only by time. That is really nice timer. This setup can really be transferred to something else. So let me show you something. What if I drop the, let's say, a bool node here and simply get rid of these guys because maybe I don't need them anymore. So I'll just keep the time node, the result, and this text, and actually this bool guy. What if you connect this to the text and hit play? You will notice that now this node actually outputs false value, and it will write that down here in the text line. So how can this be actually useful? Well, sometimes you really cannot be sure what kind of statement is outputted from your nodes. So if you change this, just enable these two values, you will see that true is the value of 1. So if you really prefer this true and false, you can simply utilize that text object to help you dissect and understand what is outputted from your node. And I'm showing you all this because it will be much easier to understand next to lesson where we will build a little bit more complicated expressions. So you have to understand the logic behind it. You don't have to understand every single node. God knows that is simply impossible if you're not some heavy coder or software engineer. But some basic knowledge of some really regular nodes is desirable. And if you invest time in that, you will be rewarded at the end because practically no setup in Sina4D will be a challenge for you because you can combine Espresso with virtually everything in Sina4D. And just to clarify something, these guys, this single node is actually, let's say, a chunk of coffee code, and that coffee code is actually Sina4D programming language, along with a Python programming language that is introduced with release 12. I could possibly show you, let's say, another thing is how to create random values between 0 and 1. So we select noise node here, actually a random node here, and select the bool value. So it will be 0 or 1. You can clearly see that. And if you will connect these two guys, you will get a true or false statement. It will really go wild. And if you want to force this to be 0 or 1 value for the text object, you not really output from this result node, and really nice node for it is actually here, and it's called spy node. It's completely the same as the result guy, but it has the output. Okay, so let me just demonstrate that for you. So this node is actually used to read out the values between two nodes, and it doesn't change anything. Really does behave as a result node. Okay, so you can now freely create those crazy 0-1 animations, clone them, and have really nice motion graphics. I think that's it for this lesson, and let me show you a really nice way to add a secondary motion to your character in next lesson.